So nonparametric tests are really used when corresponding parametric procedure is inappropriate or won't really work. And normally this is because the dependent variable is not either interval or ratio scale. So we're normally dealing with nominal or ordinal data. And it can also be used because the dependent variable is not normally distributed. Right, so you can kind of use it in both ways. If the data of the interest are frequency counts, of course, nonparametric statistics can also be appropriate. So we have a couple different reasons why we want to use a nonparametric inferential statistics analysis. And SPSS does have a really powerful nonparametric test command, and it includes enhanced reports, which will look a little bit different than what you're used to, which I think you'll like. And it does help us, the users, choose the appropriate test and really interpret the results correctly. So we're really going to get an accurate interpretation of our results. So in this video, we're going to do the chi-square goodness of fit. There's another video that does the chi-square test for independence, but in this one, it's goodness of fit. And the chi-square goodness of fit determines whether or not the sample proportions match the theoretical values. For example, it would be, you could use a chi-square goodness of fit to determine if a die is loaded, all right, so if it's like cheating at dice, or it's fair, right? It also could be used to compare the proportions of children born with birth defects to the population value, right, to determine if a certain neighborhood, for whatever reason, has a statistically significant higher than normal rate for birth defects compared to the greater county or the state or the nation. So with assumptions, with nonparametric, there are very few assumptions with nonparametric statistics. There's really no assumption about the shape of the distribution. Now the expected frequency for each category should at least be 1, and no more than 20% of the category should be expected values less than 5. And it's really just a good rule of thumb to have no categories less than 5 to really get some good data. So SPSS requires only one variable. So in our example here, we're only going to use one variable, coins, right? And this the sides that the coin falls on. And it can be measured on any scale, although SPSS requires it to be defined as nominal. So if you click on the variable view for your data set, you'll see that I did make both coins, right, that measure as nominal. So it's not interval or ratio, or I guess they call that scale, but it's not ordinal, but it's definitely nominal. Right, so we have coin 1 and we have coin 2. For the first part of the lab, I'm just going to have you guys use my data, and then of course you're going to do dummy data. You're going to flip your own coins, 2 different coins, to see if they are equal or if they're fair, right? So again, you can use your A1 thing there. 1 denotes that it's a heads, right? So when the coin landed on the table, it was a heads, and then if a 2 would denote tails. So we have 20 goes of it, right? So when you do your own 2 coins, you're going to have 20 goes of it also. So you get a quarter or a penny or whatever you want to use, and just determine if it's going to be falling on heads or tails. And so, so coin 1, coin 2. So to run the chi-square test that we're going to do first is you're going to go up to Analyze, and then hit on Nonparametric Tests, and just click on one sample, and it should bring you up this window, this one sample nonparametric test window. And you'll notice that the new procedure has a dialog box. It looks a little bit different than the dialog boxes that we've seen in the past. The interface is a little bit more user friendly, and than maybe other SPSS ones. And this new dialog box was just recently rewritten for anything over SPSS 18. So definitely if you're on 25 or 26 or 27 at this point, you should see a dialog box pretty similar to this. So again, we're going to use chi-squared goodness of fit. So let's see here. We want to click on the Fields tab. Let's see here. Yeah, second one over here. Now, sometimes yours will be, depending on how I sent this data set over, the coins will be on this side. Again, you can double click and get them over to be on this side. We want to make sure that it's on use custom field assignment. You don't want it to have predetermined roles, because it will we don't want that. We want to use custom field assignment. And then we want to go over to settings. That's our next one. And we want to do customize test and make sure it is under choose test. It's not under test options or user missing values. Go make sure it's on choose test, and then customize, and then we want to run the chi-square. There's different ones that you can run as a non-parametric test. The binomial one, I'm not even going to try to attempt this, the Kolmogorov Smirnov test. Wilcoxon, that's another big one, but right now we're just going to use the chi-square. Just double check your options here. Yeah, all categories have equal probability, because with a coin, as long as we're saying the null hypothesis is there is no, greater chance that heads or tails are going to be picked, right? There's an equal chance of you choosing heads or flipping to heads or tails. So yeah, that's fine. Sometimes when you have unequal expected probability, you can do it like that, and you can kind of say which category you want to tease out. But for ours, it's a coin, equal probability. That looks fine. And then run it. And again, it's going to look a little bit different, right? So it really does spell it out. So we have, category for coin 1 and coin 2, right? So we have one sample, again, chi-square, and we have a significance of 0.655. The decision, it's going to spell it out for you. You're going to retain the null hypothesis or fail to reject the null. Now watch also what happens too. It gets even better when you double click it, right? It brings up a model viewer. In the model viewer, you get these really awesome graphs, right? And so you can kind of see here the observed and hypothesized, and it really breaks it down with, an alpha being 0.05, what was the probability that the coins would be either heads or tails, right? So we can tell that, well, there really isn't a difference there. So the model viewer, this guy right here, this whole guy right here, expands a standard answer by automatically presenting graphs and other really awesome information, really necessary to interpret your report or results. And it's in this this model viewer that you're going to find the more standard values for the chi-square itself, degrees of freedom, so on. So a lot of juicy information in there. So for your first part, what I want you to do is take a screenshot of this entire bit, right? So I want to see a little bit of the data set. I want to see your output window here, and I want to see your model viewer. So if you can take a screenshot or a picture of this entire screen, that would be perfect. And then what I want you to do is get out two different coins, right? So maybe do like a quarter and a nickel or a $50, whatever you want to do, and then flip it 20 times and record it. And then for the second screenshot, I want to see this again, but of course you'll have coin 3 and coin 4 with your stuff in there. Awesome. I love chi-square. This is awesome. This is, again, the goodness of fit, and there's another video for Test for Independence. So you're actually going to have a couple more screenshots for your entire lab for this week, or this lab, but this one will get you going for your chi-square goodness of fit. Okay, awesome.